All right, let's start. Hi, um, welcome to today's episode of How Hard Can It Be? Um, I'm here basically. This is completely unplanned. But if you've been watching the previous episode, I decided to use the rope data structure that I created some time back. And the thing is, I didn't plan this episode because this morning I discovered for another topic completely, I needed to use the rope data structure, as I'm planning tomorrow's work, I decided to reacquaint myself with the rope data structure. See, the rope data structure, I wrote that a number of years ago. We were building a startup, AI startup, and that failed, and then one thing led to another. We had this crazy idea where we had AI powered text editor. And so during the first PAX in Melbourne, Penny Arcade Expo in Melbourne, I wrote a text editor overnight. And on and part of the text editor was having a rope data structure. I actually managed to pull out I actually managed to pull out the text editor, the very, very, very rudimentary text editor, and I can show you. So let's see, pull out this. Okay, so this is the front end of the text editor, and if you go run startup go, this is an editor, right? And the idea would be that you have the AI features that helps you with writing your code and writing your text. And this was way before there's a startup now called Kite, which gained notoriety for uploading all your code and to a server, and then putting ads or something into injecting ads into your text as you're editing them. I don't quite remember what the controversy was, but Kite basically attracted a lot of controversy. And the thing is, with an AI-based text editor, you can do quite a lot of things. Ultimately, we decided that it would not be the best use of our time, so we ended up scrapping this project. Let's see, how do I get out of this? No. Oh yeah, this is a weird mixed mode thing. And this is the front end, and the back end would be, sorry, editor back end. Yeah. So this is the back end. Yeah. So the last commit was let's see, -1. The last commit was in 2017, so it's been some time since I created the text editor that had a rope as a backing in the backend, and I don't quite remember how ropes work anymore. So in this episode, this is going to be very quickly. I'm going to explain what the rope data structure is, and I'm going to basically draw, I guess. Yeah. So um so we start off with remembering what a string is. A string is basically a slice of bytes, if you will. Now the bytes can be the character. An individual character can be an individual byte or multiple bytes. So I'll draw something like that. So this can be one character, and this can be another character. All right, so this is UTF-8. I'm just going to change my pen. So this is UTF-8, and it allows you to say, okay, this is a character. And but when you have a very long piece of string, like in a text editor, you got to do a lot of inserts and deletes. I mean, think about it. If you want to keep inserting things into a string that is this long, you're gonna have to look for the location, and what you're gonna do is you take this bytes here. Let's say you want to insert somewhere around here, right? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You want to insert here. You take you look for this location. You split up into two. One here, and this one goes here. And then you basically make a copy and then put new data in here, and then you reconcatenate them. So that's a lot of allocations involved. So that's why people use data structures like a rope. And a rope is very simple. It's basically a tree. So you have something like that, and each node here is a string itself, right? And each break in here is basically the point where you break your node, you break your long string up, and where you can insert things and stuff. I'm not sure if that's helpful, but that is what essentially a rope is. You would use a rope when you create a text editor, or in the case of the series that I'm live streaming in a LSP, you will want to store your source code in some sort of rope. And maybe you'll also want to involve a piece table, which is a sequence of edits. I'm not sure if I want to do that, but I'll talk about piece tables if I need it. But for now, we don't need it. So these are strings. And that's essentially what a rope is. And the thing about this rope is it's different, because for searching through the rope, right? So when you have a long string, so for example, I am live streaming right now. So this is the string I am, and then live streaming is in these two strings for some reason. Right now is in this final bit. When you want to search through this string, you need to walk up and down the tree, right? And that can itself be quite time consuming, so the trick to making this rope fast is that when it's searching, it's not actually using the rope data structure as a search. It's basically using a skip list, and that's as far as I remember what it does, right? Like I said, it's been 4 years now that since I wrote this. So yeah, I just want to get reacquainted to this topic, this library, because I'm gonna need it tomorrow morning, and that's for a different project that does not involve the LSP. Yeah. So the knot in here is the node, each individual node in here of a rope, and as you can see, a rope is made of a head, and each knot is basically a skip knot. Oh, what's a skip knot? Oh yes, a skip knot is basically a knot, but it has skip list features. Okay, I should probably explain what skip lists are as well. So imagine you've got a list of numbers, right? When I say a list, I mean a linked list. Okay, so you've got 1 link to 2, link to 3, link to 4. All right, could be something, right? So you have one knot here, that is linked to the next knot, or multiple nexts, if you will. And then you want to be able to skip. So this one can also skip 2, So it will skip straight to 3. So it will have one link to the node of 3, and this one will have one link to the node of 4. So this way, if you already know roughly where your data is, you can just skip ahead and then use it as a okay. So 1, 2, 3, 4 is not good because these two are associative, right? It doesn't matter if you do step 1 first and then step 2 first, or step 1 first and then step 3. So this example that I have here is not actually good, so let's not use this. But imagine you've got a very long list, then you would want to skip multiple things. It basically acts like a binary search. If you partition your skip lists in a way that is binary, then it's binary search. But the idea of a skip list is that you can configure all these little things, and I think the file name is called Skiplists. Skip probe. I'm also probably going to search. There you go, skip list. This search is basically how you search through a skip list. I'm probably also going to modernize this library, start using Go mod for this library. When I wrote this was before Go mod was a thing. So yeah, I'll clean up this library. It's currently version 1. I can retag it as a new version 1. There are some failing tests. Well, not really. All the tests pass, but the fuzz test that I put this library through a fuzzer and I did not solve the fuzzer issue. And I don't remember what the fuzzer issue is anymore. So yeah. Okay, so just to reacquaint myself with the data structure, a rope is basically made of knots, okay? And a knot has children. Children's are skip knots, and skip knots are basically number of bytes between the start and current nodes. Okay, so a knot is basically a node with a fixed data bucket size. So bucket size is 64 bytes. So when I mentioned that this string, it's going to maximally store 64 bytes. And after 64 bytes have been stored, it will be moved to a next node, and there'll be shares of stuff like that. Okay. Yeah, a knot is a node in a rope. Haha, very funny. I'm very funny. And height is basically, well, how high each of these things are. And use this. Okay, I documented this library quite well. I had a look at the skip list, and it wasn't well documented, so that could be some fun archaeology. So that's what a skip knot is. Skip knot basically is a knot with some meta information on. Oh, okay. Yep. Okay. And then the rest of this file is basically all the API for a rope. What can you do with a rope? So a rope would return a size, obviously, and return a number of runes. Okay, you can substring it. Substring, not really a string. It's subtreeing. Sub-roping, I guess. Substring. So. Example, Nihao world has a length of 11 bytes, but if you only want how, you have to call substring bytes 1 to 2 because okay, that's interesting. This is a bit yeah, so I don't quite remember what the story for this is, but at the last minute, I do remember asking Egon Albrecht for help, and he says he gave me advice on whether to work on pure bytes or runes. I think one of the original design was that instead of strings, it was a slice of rune, and a slice of rune is a slice of 32-bit integers representing a character. Now that's fat, quite fat, because with UTF-8, a single byte 0 to 255 can represent a lot of characters there. Yeah, but at the same time I also wanted this to handle just more than just ASCII, right? So yeah, so I converted everything to bytes, and there's some weirdness to it. So there's insert a substring, yep, insert bytes, insert runes, and insert, which are variations of the same thing. And then there's erase and index. Yes, so byte offset would then take the original string, and given a location in this rope, I can find the byte offset in the original string. Yeah, okay, that's a very interesting one. Before, and there's a writer, obviously. There's no reader. That was actually listed in the to do. Like readme. Yeah, so I went through this in the last bits of the last episode. I will go through this again on how to keep track of row and column information. So it did implement IO writer, didn't implement IO reader. So I personally don't have the bandwidth. Okay, I still probably don't have the bandwidth for it, but if I have to use this library, then I might do some minor upgrades. All right, so let's look at the skip list. This one's not documented, and that's fun. So this thing makes it fast, right? Yep, it's a skip list. It's made of a rope, and then it basically casts the rope as a skip list. It uses nexts. Okay, this creates a new. Okay, find the point. Okay, it goes through the list and goes through how many skips there are, and then if the offset is greater, yep, then we know that we can just jump ahead using the skips. Otherwise, we'll go down the skip list, and that's what the height is for. So yes, so the other way you can think about this is you can think about this as a skip list. These are the jumps. These top bits are the jumps. So there is a link like that, and then there's a top bit that is essentially a jump for you. Okay. Find and find two. Now that's interesting. Find blocks for insertion and deletion. No counts for byte offsets are required. Oh yeah, there's because this is an impromptu live stream. There is a 30 minutes. There is a 30 minutes. What do you call it? Oh no, I didn't set my timer. Oh dear. So there is a 30-minute limit to this because I need to go to sleep. Okay, so insert basically inserts a new knot with a given data. Yep, it checks whether it's past the bucket size. And then it counts the runes in the data. K.use plus byte count. Yep. So check if it can insert. If it cannot be inserted, and the OffsetBytes. OffsetBytes. So the OffsetBytes is basically the spare. Imagine that you've got in an inside a node, right? You got a string, an array of, well, bytes. This is an array. and it checks if this thing is bigger than the bucket size. Let's say we used it until here. So everything before this this 64-bit array, 64 element array, let's say this is element 60, okay? Everything before that is used. So we have new data coming in, and let's say the new data is just let's just say the new data is 4 bytes. Okay. I think that's the case, right? It's yeah. Is that what it is? That is, it's not S0. Okay. Ah, right, height. Okay. Okay, so if the offset bytes is basically the things that can be moved into a new bucket somewhere. If it's not new, then we can actually put it into the next bucket. So we can look at the next bucket and put it into the next bucket, and we'll say that yes, we'll put it into the next bucket and say that it can be inserted. So once it can be inserted, then we have to do some copying, right? We have to move. So whatever that's in the next bucket, so this is the next bucket, whatever that's in here, this thing needs to be moved in the exact amount. So as the incoming offset, incoming data. So that the incoming data can be moved in here. Does that make sense? Or am I just randomly drawing boxes now? Okay, otherwise you need to add a new knot, a new node to the tree. And then put the data in the new knot. Okay, that's very easy. So that's the skip list used to search for things. So this is a knot. And deletion. All right, so I think I understand how this thing works. Now it is a bit faster for me to understand it because I wrote it, and it is somewhere at the back of my head. But yeah, if there's anything that is not clear about this, I guess you can always ask me. I should do some maintenance work on this. Let's see, what tests do I have? Let's just call skip probe. Okay, now go mod init github.com/skip. Oh, you can do that. Wow. Go mod can do that and can copy from go package.log. What? That is so cool. Okay, I did not know that. Yeah. Okay. So this is now. Let's check the go mod before I run go test. Go.mod. Okay, sure. I don't know why these things are needed. Okay, so this is used for tests in benchmarks. Okay, I know what. Okay. Um, Okay, so there's okay, I'll fix that. Basically, what you do is to get rid of these things, which is not necessarily part of the library, you go into benchmark vs, put a go mod in there, and it'll keep quiet. It'll keep go mod quiet. But for now, we can go test. %91%. Woo. Okay. I did not know I wrote such highly tested libraries, but that's definitely a surprise. All right, so yeah, I think that's it. I I am confident that I understand this library. I'm quite sure that there was some fuzzing related stuff. Yeah, and I think I understand this library. If you've got any questions, you can ask. I'm always available via email. Uh, you know what? Let's just put it in, right? So if you can see this, let's test OBS and see whether I know how to do OBS things. Okay, select fonts. Yeah. That's very big. Who cares in the world? Why do I have a drop shadow? Okay, that's pretty cool. Oh wow. All right, so that's my email. Send me an email if you don't know how this thing works and you want to ask me a question about it. Um, other than that, thank you. This was a very fun exploration of the things. And this was really impromptu. So yeah, thanks for watching. Catch you later.